Hello everyone. So we are in the part 2 of the SPARQL unit. So in the last lecture, we have started talking about different constructs that are useful to write different queries to get answer from the RDF dataset, right? So in the last lecture, we have talked about the syntax or the anatomy of one SPARQL query, and then we talked about different graph patterns like basic graph pattern and optional graph pattern, and then finally we stopped discussing the negated graph pattern, right? So today we will continue the discussion, and the next graph pattern that we like to start with is the union graph pattern. Right. So by the name, you can really guess that what this graph pattern really points to, right? So you basically have two sets. So if you take this particular example, so here what we are trying to do is to find out the companies that are under, say, internet companies. So those are internet companies as well as semiconductor companies, right? So if you can remember the query that we worked with in the last lecture, so this is the part which is kind of common to every query. So we are trying to find out whether some entity is a type of company or not, and then we are trying to find out the label of this company. This is basically the string label, and then we are trying to find out the industry of this particular entity, right? And we are storing that value in the variable industry, right? And also we are applying one filter that I want the company names to be in English, right? Now the next part, so here we have listed down all the companies, and they have some value in the industry. So this industry value can be software, it can be, say, semiconductor, it can be marketing, many things, right? But out of them we will try to retrieve the companies that are of type internet or works in internet domain or work in semiconductor domain. So we are using the word or, and this or is modeled using union, right? So if you look at this particular triple, so this particular triple will be a set. This will bring you a set, and this particular triple will bring you another set, right? And all this triple, so irrespective of whether it is coming from, say, internet or semiconductor conductor, so these three triples, they have to be satisfied, right? Now we take one union of this. So one company might belong to both internet and semiconductor. That will be coming as our output. And you know the basic notion of union. By the basic notion of union, we can list this company, list this company, or a company which is kind of happening or appearing in both the categories, right? So let us try to run this query and see what is happening, right? So we're moving to the dbpds SPARQL endpoint. So this is the query we are trying to run. So yeah, so we put it here, and if we just say go, so you can see that we have the companies like helium.com, which is of type internet, right? Or maybe say going down, let me find out some semiconductor thing. So okay, so you're trying to find the whether we have a company in the semiconductor domain, right? So you can see that there are many companies like Texas Instruments and others there in semiconductor domain, right? But on top of this, you can see that you have the companies that are working in the domain of say cloud computing or financial services, which were not really the thing we wanted. But why they are getting listed? Because if you take this umbrella worldwide corporation, so this is belonging to the internet domain. So that's why these companies retrieve. But this company is also working in financial services, information technology, and internet hosting service. So these are also retrieved, right? But it will retrieve at least that company is either internet or semiconductor. So going back to the queries, okay. Now, there might be situation where we need to query multiple graphs, right? So you want to satisfy, so it may so happen that the data set, it is distributed in different data sources, and you want to write a single query that will take input from different databases and try to find the answer to the question, right? So let us try to see the databases or so we have small databases like example 004.ttl, example 005.ttl, and example 006.ttl. First, let us look at what we have there, right? So, okay. Uh, so, yeah. So we can see, okay, let me open the files. Example 4, 5, and 6. So 4, 5, and 6. So, okay. Uh, so you can see in example 4, we have the actors and their information. Like say Christian Bell has got name to be Christian Bell, the nationality to be British, and gender to be male. And you have got entries for the other movie actors, right? And let us go to 5. What we have? We have got the movie names and their corresponding titles. And what we have in 6? In 6, we are saying that an actor acting in a movie. For example, Christian Bale is an actor in Dark Knight trilogy, right? And the other examples as well. So what is our query? Let us go back to the query part. Our query is so we want to retrieve the name, nationality, and the movie name where uh, mm, the entity has got name to be name and the nationality to be nationality and acts in a movie, and the movie has got a title, and we are retrieving this name, nationality, and movie name, right? Now you can see that in one file, so for example, example 004.ttl, we have got information about the name and nationality of a person, right? In example 5, we have got the movie and the corresponding title. And example 6, we have got which actor acted in which movie. So this single query will go to fetch data from different places and try to find out the answer by combining the triples out from the different databases, right? So let us again go back to the command prompt to run the query. Okay. So this is the query. So we have got the single query. This is to be run ex007.rq, and these are the 3 data sources that we want to query, right? So if you execute this, so you can see that we have got results like Christian Bale has got nationality British and acted in Dark Knight trilogy, and say Morgan Freeman is one American person and worked in say $1 Million Baby. So you can see that the information has been collected from different data sources to satisfy the or provide the answer to the query, right? So, so this is one way to query multiple data sources or distributed data sources. But there is another way. I guess that is a more elegant way where you have something like this. So, what you have, you have a complete data space. So, this is your complete entire data space. Entire data space. Now, this entire data space has been presented in a modular way by putting the data in different graphs. So, for example, G1 holds some data, G2 holds some other data, G3 holds different data, and G4 holds another set of data, right? So, there might be overlaps, but they might be different data sets altogether. For example, I have provided an example in the last class that if you are trying to create a data set for, say, in sports domain, so you can create a data set of the related to cricket in one graph, related to football in another graph, and for other sports in other graphs, right? Now, when we put forward a query, so what happens? So we have a default graph. So we start with a kind of null graph, and if we say that I want to query from G1, then all the triples will be coming to the default graph, and the answer will be satisfied using this default the data that is there in the default graph. But at the same time, you can say that I want to access the graph 1 and the graph G2 to satisfy my query, right? So that requires that your graphs, they should have names so that you can identify the graphs, right? So if you think about a typical RDF store, which we also call as a triple store, it is a collection of graphs. So for example, G1 is a collection, G2 is a collection, G3 is a collection, G4 is a collection, and each collection contains a set of triples. So for example, G1 contains the triples T1 and T2, G3 contains the triples T3, T4, T5, and so on and so forth, right? So this is a kind of structure of an RDF store, right? Now, how will you query? So this query can be done again in a very modular way, right? So let us look at a query like this. So we are selecting something. If you say star, it will output every variable that appear in your where clause, right? Now, following select, we have from, say, from G1, from G3, and then this is followed by something else like from named. So this is a special keyword we are attaching on top of, say, from, right? And then you are saying that from named graph G2, and for the other case you are saying that from named graph G3, and finally named graph G4, right? And let us look at the patterns that you have in the where clause. So first pattern is a basic graph pattern, which is very simple. But the other three patterns, they are starting with a keyword graph. So these patterns are called graph pattern, because they are involving graphs. And what is following this graph keyword? You can have one variable, or you can have one URI, right? And you can correctly guess that this URI is a URI of a graph, right? So you are saying also a graph G1 BG. Now let us try to analyze what are the kind of meanings we can associate to each of these patterns. Now this basic graph pattern will be checked on the graphs which are not named. So this will be checked against non-named, checked against unnamed graphs. So unnamed in the sense we don't put one named keyword here. So we don't put one named keyword after the from keyword, right? So this G1 and G3, they will be available to check this BGP, right? Now coming to the next pattern where you have got this graph followed by one variable, right? So what it will do, it will try to look at whenever we start a pattern weight graph, it will always look for the graphs that are coming under this named category, right? So this G will be instantiated with G2, G3 and G4, right? And this BGP2 will be checked against G2, G3 and G4, right? Now look at the third pattern. So here we are explicitly saying that we want to query from G4, right? So this will be checked against G4, right? The BGP3 will be checked against G4, right? And finally, we have G1 and we want to check against, and this BGP4 will be checked against G4, G1, right? Now let us, we have this data, a concrete data, and let us try to see what kind of triples will be available for each pattern, each of these patterns. So this BGP, so as this is being checked against G1 and G3, T1, T2 and T6 will be available. So basically this, this and this, because we are considering G1 and G3 to be the graphs which are not coming under from name. So they are coming under only from. So that's why they will be available to check the BGPs, the simple patterns, right? Now the next pattern, this graph variable G, then BGP2. So here we will be having all the named graphs like say G2, G3 and G4. So this G2, G3 and G4 to be available to check this BGP against, right? So this BGP3 will be checked against the triples that are there in G2, G3 and G4, right? So basically the triples in concern for this particular pattern are like T3 because we are taking G2, T3, T4, T5 and then G3 we are taking T6 and finally G4 which is T7 and T8, right? The next pattern, as it is explicitly saying that the BGP3 should be checked against the graph G4, then only graph G4 will be brought to the default graph, right? And BGP3 will be checked against this T7 and T8, right? And finally, what will happen for this? So you see here we have taken G1 uh, to be a parameter of the graph, right, of this pattern, right? So that means that G1 should be a named node, which is not in this case because this G1 is not a named, it is not following this from name command, right? So it will not be available to be checked against BGP4, right? So that's why there will be no triple against which BGP4 can be checked, right? So these are the all possible patterns you can have concerning the named graph or simply from graphs, right? So only thing to remember is that whenever you have a from graph or the graph that is under only from or defined under only from, then it will be used to check the BGPs. So the simple BGPs will be checked against the graphs which are not coming under from name. So example here is BGP1. But for the others, the patterns that are starting with say graph, then only the named graph will be used to check the BGPs that are inside this graph pattern, right? So a graph pattern, if we try to summarize, so one graph pattern, so what it will have, it will have the graph keyword, then followed by one URI. So basically this is the URI of a graph which is under from named, and finally a set of BGPs, right? So this is how you can represent one graph pattern. Now with this description, let us go to some examples, right? So we will be taking these examples we have already talked about, but we have extended that a little bit. So we are having new files like say ex007.ttl and ex008.ttl. So let us have a look at those what we have there. So 7 and 8. So in 7, we have all the data that we have seen, that 4, 5, and 6. They have been consolidated and put in a single file. So the 7 is basically a union of 4, 5, and 6, right? And what we have in 8, we have in 8 information about different other actors, like say Anne Hathaway and Robert Duvall or Amitabh Bachchan, and we have got an entry for two movies here, right? So now we'll be querying multiple graphs, but we'll be using the from keyword, right? So we'll be using the from or from node keywords. So let us try to look at the query first, then we'll be executing the query, right? So we are saying that we want to select name and nationality from the data sets EX7 and EX8, where an entity has got a name and nationality to be nationality, right? So what it will do, it will take out, or it will not take out, it will take or copy all the triples from EX7 or EX08 and put in a default graph. So this is your default graph. At this particular BGP, so this is your BGP will be checked against this default graph, right? So you don't have any named graph here. So all the data that you have in 7 and 8, they will be coming into picture to answer this query. So let us run this query. Well, so we have RQ9. So the query is ninth query. So this is the query that we want to run. Now you can see that we are not having this data as argument, because we have put the data, the reference to the data in the query itself by means of writing say from EX008 or EX007. So if you execute this, so you can see that we can retrieve the data about all the actors like Christian Bell, Morgan Freeman, and Maggie from the file I think 007, and Robert Duvall, Amitabh Bachchan, and Annie Hathaway from the file 008, right? So as they have been put under only from, so all the triples they are coming into picture while answering this query, right? Now let us try to use the from named part, right? So here we have just changed this particular line. So this particular line, so it was earlier written as only from. Now you have changed into from named, right? And you can guess what will happen. So you don't have anything special here. So this is a kind of BGP we are having. So this BGP will check against only this graph, and this graph, that is 008, will be completely ignored, right? So let us try to run this query in the form of query 10. So we have query 10. Now you see that we do not have the entry for Amitabh Bachchan, Robert Duvall, and Annie Hathaway here. So as they have been, this particular graph has been put under from named category. So those triples are not coming into picture while answering this query. Now let us take another situation. So here we have taken this EX007 to be the from graph, EX011 to be the named graph, and EX008 to be another named graph. But here we are saying that we want to retrieve the actor name and the add a movie and the movie title, right? So what you can see here, we have just presented EX011TTL as the second parameter of the graph pattern, right? So graph pattern. So you are specifying one graph pattern, and the second parameter is a very concrete URL, which is the dataset, the reference to the dataset EX001.TTL, right? So what will happen? So you see that this will be coming into your default graph. So this will be coming into your default graph, and this will be coming into your default graph. So all the triples from EX007 and 00011, they will be coming into default graph. But this 008.TTL, no triple from this graph will be coming into this default graph. So the query will be answered based on the triples that you have in 007 and EX011. So let us have a look at what we have in EX011. So in EX011, we have got entries for few more movies like say the Intern, Deep Impact, and Agnipath, right? So and what we have put in the default graph or from graph 007. So you have got 007, which lists Christian Bale, Morgan Freeman, and Maggie, and a set of movie and the actor acted in the movie and the movie title. So what we expect? So we will expect that we'll be having the actors who are in 007 or 011. So in 00011 we 011 we do not have any actor, we have just the movies, right? And 007 we have got the actors, right? And in the graph pattern that we have in the graph pattern, so there we have asked for the movie titles, and we can see that in 007 we have got the movies and the titles, and in 00011 in 11 we have also got movie and the title, right? So let us see what we can see as output. So we are trying to run the query number 12. Sorry, I ran query 13. So you got to run query number 12. So you can see that the actors, they have been retrieved from the graph 007, and the movies, they have been retrieved from 011, right? Because that pattern, this movie and the title pattern, that is coming under the graph pattern, right? But the movie and the actor and the name, that particular triple is coming in the default part of the query. So let us go back to the query and try to analyze. So so what we have, this part will be coming from the default, that is 007. So in 007 we have got the actor and the name of the actor. But in 0, 1, 1 graph, we are having only this movie and the title. So this movie title will not be coming from this EX007 TTL. It will be coming only from this EX011 graph, right? Uh, we can also, so in the last query, what we have seen that we have just mentioned explicitly which resource or which graph we want to put in our graph pattern, right? But you might be having multiple graphs, right? So and you want them all to be named, right? So or whatever named graph you have, you want to make use of those triples, right? And the simple way to do that is just to replace this concrete URI with a variable, right? So in the first instance, this will be instantiated with say ex011ttl. In the next instance, it will be instantiated with 0008.ttl. And you know that all the triples like say ex007ttl, ex01ttl and ex008ttl, they will be coming into picture, right? But you need to consider that this particular triple will be matched against these two graphs or the triples from these two graphs, but not the other graph, right? But this will be checked against this graph, the triples from this graph, right? So what we have